Traditional machine learning takes place in a centralized approach. So for instance, when companies such as Google or Facebook want to train a model, they require data from their consumers. The data from the consumer is passed to the central server, which performs the model training. Once training and testing is done on the central server, the model is then distributed onto client devices. However, this means consumer privacy has been compromised. This is where federated learning comes in. Instead of transferring data from the devices onto the central server provides the model to the devices. The devices train the model and then sends it back to the central server, which performs some sort of aggregation. And once this aggregation is done, it serves the model back. This goes on until a certain number of rounds have been reached, after which all nodes will receive the same model. However, there are certain problems related to federated learning, the biggest of which is communication costs, as well as model accuracy, model variance, and problems with algorithms. We intend to solve this with a scheduling algorithm. However, in order to test this scheduling algorithm, we need to create a federated platform to emulate the network settings as well as the creation of these nodes. The platform must also be able to record metrics such as network cost and model accuracy. In this project, we'll be using the Mininet image as well as a federated learning library named PySafe. Using Mininet, we are able to vary the network capability of each node. Each node will be running the Python library, and Mininet allows us to scale up the amount of nodes that we have. As part of this federated learning infrastructure, each node had a different dataset size as well as a different network capability. In addition, changes were made to the PySafe library such that nodes could send their dataset size as well as their network capabilities over to the central node. This was crucial because it was essential in our scheduling algorithm. Let's take a look at how the infrastructure works. We run this command and it creates the worker nodes as well as the controller node. Each worker node has a different network capability as specified, as well as a unique set of data. Each node is initialized as a batch process in the Mininet image. In our test environment, we have 10 nodes. Not all nodes would train during one round of federated learning. We can see the central node obtaining the network capabilities and dataset sizes of all nodes. Once this is done, the central server can use this matrix in the algorithm to determine which nodes to train on first. In this case, the central node has chosen H2 up to H5 for training. Hence, in part 1 of this project, we have managed to create an image with the Mininet environment as well as PySafe, created an infrastructure to test our scheduling algorithm. Using this, we can effectively test our scheduling algorithm and determine which hyperparameters to adjust, as well as make certain conclusions.